what you will see in the heat exchanger. Okay, the real practice, the real situation. Okay, yep. What else? Okay, and you see, you need to use Vmax, right? Maximum velocity. Okay, so why you need to calculate maximum velocity? There are two situations. One is when the tube arrangement is in line. Another situation is when the tube arrangement is staggered, right? Okay, let me explain to you why it happened. Because I don't want you to just memorize. I want you to at least to have some understanding, so that you don't just depend on your memory, but when you understand, you know the logic, and then you know what to use. Okay, why you need to get Vmax? Okay, why there is a V change? This is the first thing we need to ask. Why? Okay, because when you solve problem before this, you only use the V provided, right? Okay, V is given to you, then you just use the V in order to calculate the Reynolds number, because it equals to raw Vd or raw Vl divided by mu. Okay, before this, all those cases, for example, cylinder, single cylinder, floor pass, single cylinder, floor pass, a flat plate, or a sphere, you use the V directly, right? But now when you encounter with banks of tube, then you need to calculate Vmax. Okay, why? Because there is a change of velocity. Okay, there is a change of velocity. You see, the fluid flow past this with a velocity, but when it enters here, okay, you see, when it enters, before it enters the banks of tube, the velocity is constant, right? But when it enters the area, then it faces about hindrances, right? All these tube hinder the flow of the fluid. Okay, when it faces hindrances, it means initially, you see, initially the area for the fluid to flow past is big, right? But when it comes into these banks of tubes, the area which allow this fluid to flow becomes smaller, right? Becomes smaller. So when you come back to the conservation of mass, okay, so at this area, the area is big, right? We want, if we assume conservation of mass, okay, so meaning at this point, this amount of fluid is passing through per second, right? But here we have smaller area for the fluid to pass by. So what will happen to the flow? If we want to maintain the same amount of fluid to flow past, what will happen? Of course, the V will increase. You need to flow faster so that the same amount of fluid can pass by. This is because we assume conservation of mass. Same amount of fluid flow past, regardless it is in this area whereby there is no tubes, or as compared to when it flow past this area whereby there are many tubes. We want to ensure same amount of fluid flow past. So there is only one choice if you want to assume conservation of mass. That is, when it flow past here, the V will increase. It flow faster. Okay, this is the principle. So that's why when we consider banks of tubes, when we calculate Reynolds number, we must use Vmax. Okay, because there is a change of velocity. The fluid, when before it flow past the tubes, it flow slower, right? V initial, let's say, is slower as compared to when it flow past the tubes, then the velocity increase. Okay, so when we calculate Reynolds number, we must use the Vmax instead of the V enter. That is the reason. Okay, so how you calculate? That use the formula, right? How this formula comes from? You see, this is the initial V, right? This is the Vmax, and this is a ratio. What is the ratio? The ratio is actually, what is this? ST, right? ST is this. ST minus D. This is D, right? So this is actually a ratio between this area, this surface, as compared to ST minus this. Meaning, it's actually, this actually is the ratio of this area to this area. Okay, this is ST, and this ST minus D, this ratio. Okay, this ratio. So, because initially the flow, the area available for the flow to pass by is this, right? But after it enters, it faces these tubes, the area allowed for the fluid to pass by becomes smaller, becomes ST minus D, right? Become this area. So this is the ratio of velocity increase. So that's why Vmax become this ratio times initial V. So this is the logic behind this formula. If you understand this principle, you don't need to memorize. You also understand. You also need to, even this formula is not given to you, you also know how to calculate because you understand the principle. Okay, this is of course for inline, right? For staggered, a little bit complex. Why? Because for inline, you see the area, they are all the same, right? They are all the same. But for staggered, it's a little bit different. First, it's passed by here, right? Then after that, it passed by here and here, right? So meaning this area. You see, AT, A, and AD, different, right? So it depends. It depends on what is your SL. Okay, it depends. So the SD actually depends on what is your SL and what is your ST. Okay, because the arrangement is different. So that's why for staggered, the calculation is a little bit different. But actually, you can use the same formula. Okay, so you actually don't need to memorize this. Okay, you only need to calculate. You only need to calculate this lah. Okay, you use both. Okay, you calculate Vmax using this formula. You also calculate Vmax using this formula. Okay, then you see which one is higher, right? Then the higher one is the Vmax. To put it simple, because what we want is when we calculate Reynolds number, we want to use the Vmax, V maximum. That is the key, right? So actually, you don't need to memorize. You don't need to memorize, or if this one is bigger, so I use this formula. If this one is bigger, I use this formula, right? What you need to remember is what you need is Vmax. So you can actually calculate using both. Then you see which one is bigger. Then you use the bigger one as your Vmax. That is a simpler way lah, in doing this. Okay, I want to lighten your work. Okay, so you don't need to like memorize. If this case is this, if that case is this, right? If you understand the principle, what we need at the end of the day is actually the Vmax, right? Okay, so I think that's the rest has been explained by Dr. Nadia, so I will not repeat. Yeah. Okay, another thing, maybe after this you can try this example. Which one? Let's see. Maybe you can try this example. This example, the difference is you see the air pressure is lesser, is greater than 1 atm. Right? Maybe you can try. In this case, right? Because air is compressible, right? Air is compressible. So in this case, air is higher than 1 atm and is double, right? So if it is water, or this Malay, air, okay, if this water at this pressure, I think still okay, because water not that much can be compressed, right? But if it is air, air is compressible, right? Then you need to consider pressure. Okay, you need to use, if you still remember what you learned in thermodynamics, PV equals to nRT, right? Then you need to do some correction. Okay, you need to do some correction when you calculate the what do you call that? The mass flow rate. Okay, so density of gas, because density is greatly influenced by pressure, right? Because when you compress the gas, then density increase, right? So your density, because when you calculate Reynolds number, it equals to rho V E over mu, right? This rho actually affected by the pressure of the gas. And actually, what you get from the table are all at 1 atm, right? So you need to do correction if the gas is not at 1 atm. Okay, using the just now I mentioned the ideal gas law. Okay, so this is one thing I want you to take note. If the gas is not at 1 atm, then you need to be very careful. Okay, unless you can get a table, right, which provide you the density of that gas at that particular pressure. Okay, so what else? Second thing, when solving problem regarding convection, your ability to do fast interpolation is beneficial, right? So that's why Dr. Nadia asked you your first assumption, especially those problems require you to assume, let's say, TB in is given, but TB out is not given, right? TB out is not given. In this case, when TB out is not given, then you cannot get your TB average, right? You cannot get the right TB average, then because your raw, your mu, everything is at TB average. I'm talking about flow inside pipe, flow inside tube. Then because this is not available, so you have to assume, right? You have to assume. Then when you assume, right, instead of Dr. Nadia explained in the lecture already, right? When you want to assume, you assume a TB average, a TB average which is available in the table, right? Which is available in the table, so that you don't need to do interpolation for the first round. Okay, so I hope you catch this point, so that it saves your time. You don't need to spend too much time in doing interpolation. Okay, this is a very important point. Then number 3, be careful so that correction need to be done is not skipped, right? You need to understand. So when L over D is less than 60, right, for internal flow, then you need to refer to what H, then HL equals to what? It depends on your L over D ratio, right? When L over D ratio is less than 60, then you need to do correction. Okay, then for the case of banks of tubes, when the number of tubes in the transverse direction or in the parallel with the flow direction is less than 10, then you also need to do correction, right? So remember correction. Then next is when doing try and error, choose the assumed TB out wisely to avoid interpolation at the first iteration. This is what I mentioned just now. Okay, so these are all the important points I think you need to take note when you solve problems. Okay, I think I'm done with the summary of forced convection. Coming Sunday, our plan is for you to go through, maybe we will spend 1 hour for you if you have any question. Another 1 hour is for you to go through natural convection. Okay? Our plan is to complete convection, the topic of convection before Raya, before the sand break. Okay, so that we don't need to rush after the Raya, so that after the Raya we can start right away a new topic, which is heat exchanger. So I open for question. Do you have any question on forced convection? Any question?
Doctor.
Yes.
So basically, for in the test one, right? Like, if the question asks for like predict the convective heat coefficient would be just try and error lah.
I will not tell you what type of question would be asked.
No. I mean if like the type of question I ask us to predict the convective heat coefficient, we just need to do try and error for the heat coefficient, right?
I don't get your question actually. What do you mean by predicting H? Predicting?
No, because I have done some past year the question asks for predicting the convective heat coefficient of something like A lah.
Mm-hmm.
Yeah, so for that kind of question we do try and error, right?
Why? It depends on what are the information given to you, right? Like I mentioned, only one situation when you are not able to get, because, okay, I don't want you to memorize, understand, okay, try to understand. What you need to do, first step, you need to calculate, you need to determine Reynolds number, right? In order to get Reynolds number, rho V L or rho VD divided by mu, right? If any of this information is not available, because your rho, your rho and mu, normally it's like this, rho and mu depends on temperature, right? Depends on the bulk temperature, TB average of your fluid. So if you know TB average comes from T in plus T out divided by 2, or for external flow is TF, and TF is T wall plus T bulk divided by 2, right? So if TI or T out, TI or TO is not, either one is not given, then you cannot get TB average, right? Then you need to assume. When you need to assume, then of course you need to do try and error lah. You got what I mean?
Yeah, okay.
I don't want you to memorize, or if the question say predict, or then it means you need to do try and error. No such thing. I want you to understand. Okay? Understand. Okay. First step is to get Reynolds number, right? Or in order to calculate Reynolds number, I need to have all this information, right? And then to get the mu, to get the rho, I must have TB average. Then if the information which I need in calculating TB average is not available, then I have to assume. When I need to assume, then I need to verify. Then in order to verify, then meaning I need to do try and error lah. So that is the flow, right? You got the point, yeah?
Yeah, okay.
It is the same actually, guys. It's the same. If we want to so-called trick you, right? It can be very easy if you don't understand, right? So, but when you understand what you need, then you know. In some situation, when some information is not available, then you need to assume. Then when you need to assume something, of course you need to verify it. When this happens, then most probably you need to do try and error. Yeah, that's the key lah. Any other question? Any other question, guys? For the banks of tube example, right? Actually, the solution, that example is available in your textbook. Okay, in your textbook. I understand that there could be confusing. Like when you calculate heat balance, then you need to use this TB. When you calculate this, it's like different from what you understand before this, right? But I want you to go through the example in the textbook in page 275, if I'm not mistaken. Okay, go through that. Then I will also go through that. I haven't got the opportunity to go through that, to be honest to you. So I want you to go through that so that you can understand, right? Then if I found there is any so-called confusing thing which require explanation, then in the coming lecture, I will do that lah. So what I want you to do is, I want you yourself to go through that as well. Okay, because when you go through that, you go through the thinking process, then you will remember it longer. Okay. So, one more thing I want to share with you. Okay, why you need to, why you use, because in the example, when you want to verify your T, because in that example, the T out, the banks of tubes, now I'm talking about the example of banks of tubes, okay, which require you to assume T out, right? Because in that particular example, T, the temperature in is given, right? But the temperature of the heated air is not given, right? T out is not given, but T in is given at, I think, 15 point something, right? So in this case, so you don't have T-bar average. You don't have a correct T-bar average because you need to assume, right? So you need, after calculating the whole process, then you need to verify if your TO assume is correct. Is it correct or is it wrong? Normally it's wrong lah, right? So you need to verify using heat balance, right? Heat balance. Heat balance is Q is mCp delta T, because this delta T actually mCp is T out minus T in. Okay, why you use this formula? Because the concept is the heat being transferred, okay, total heat transferred from this tube to the air, right? Because this amount of heat you calculate using a H delta T, right? Okay, and this heat, this amount of heat being transferred from the hot fluid to the air through the banks of tube, okay, this amount of heat is actually, it should be the same as the heat used to heat up the temperature of the air, right? So that's why you use this to verify if your T out assume is correct. Okay, I explained about this because the same thing, I want you to understand the concept behind that so that you don't need to memorize so many things. Okay, because if you understand, you learn in what is that? Energy balance, right? This is a very common equation in energy balance, right? Q equals to mCp delta T, right? This is the heat required to increase or decrease the temperature of an amount of matter, right? Amount of either gas or solid or liquid, right? Cp is the heat capacity of that material, right? You also learn this in high school. Okay, when this amount of heat is given or when this amount of heat is taken away from this amount of gas or liquid or solid, then the temperature of this amount of gas or liquid or solid will change. Depends on how big or how small the heat capacity of the material is, right? So it is under this concept, okay? We use this formula to verify if the T out we first assume is correct. Okay, so this is what I want to share with you. So don't just follow the step without understanding. So if you understand this basic concept, then you find it much easier for you to follow, to do all these steps, because there are many steps, right? There are many steps. So if you only depend on your memory, it's very difficult. Okay, so but if you understand this basic concept, then it helps a lot. It really helps a lot. Okay, that's all I want to say. Any other question you have? Okay, if there is no question, next week, as I mentioned just now, our plan is to complete the topic of convection. Okay, so we will give you something to do on natural convection. Actually, the concept is similar. If you understand the forced convection, I don't think there is any problem for you to catch the natural convection. Okay, then of course next week's Monday night, 9 p.m. It will be the test 1. Okay, yeah, and we will also give you some exercises like your group assignment 2, right? Group assignment 2, there were 6 questions, right, for each group to solve. Then we will also give you group assignment for the topic of convection. Okay, that's all for today.
Thank you, Doctor. Bye-bye.
Okay, bye.